episode of FUM0137 machining is all about dovetails. I will be setting up the workpiece in the mill and then make dovetails.
Okay, press the screw under. Oh yeah. Now it should lift off. Oh, the oil is sticking it really badly. And then this one, like that. Oh yeah. Well, not too bad actually.
Well, here's the workpiece in the milling table. Yet to be aligned, but what I'm going to do today is to mill first corners off from here. In this side it will be something like 20 millimeters times 10, and this corner 10 times 10. And when these pieces are off, the next thing will be to create the dovetail here and here as well. So now what I'm doing here, I have just manually put this piece into there, clamped it in the middle with this and tightened it, snuffed it in, because I want to measure how plain is this piece. In this direction I can accept quite big differences, actually in excess of 0.1 millimeter, really. But in this direction, this x-axis, maybe 300ths of a millimeter, maybe, because the movements are really small, and if it's 300ths of a millimeter for the entire length, then the height deviation is really small. So let's see, I have set up another camera here so you can now see in this corner here the dial. I try to make it so that you can see. So we first measure what's the x-axis play here. So this was something we needed to be really accurate. And it looks like we are, well, this is okay. 200ths of a millimeter, and if that, because the surface is not very plain. As you can see, it deviates here and then there 100ths of a millimeter. Okay, that's okay. Yeah. Okay, I can rely on this type of clamping. Then let's, so I don't need to seam it or anything, it's okay as it is. So then this play, this direction, well, it's a little bit more actually. This becomes, well, it looks like we have 400ths of a millimeter total. Well, I believe it's okay. Let's go back and see if it goes back. If it goes back to 0, yes it does. And it's a linear movement all the way, so this means that it's really tilted. So not warped or anything. Okay, so next step will be to align it this way into here, and that's critical. Well, I have now put it quite roughly into there. What's the difference here? We should get these dead nuts, and we are having 100ths of a millimeter this direction from the center, and the other direction, well, a little bit more. 1.5 hundredths of a millimeter. So this side is low. So now I very gently tap it towards the 0 and let's see what happened. Well, as you can see, it's dead nuts. So now I tighten it and hope it doesn't move. Yeah, it did not move. Okay. Roughing cut. My weapon of choice is this roughing end mill. And well, this is an ER40 collet. Well, it's clean. I always clean them really thoroughly. And just see, okay, it's in low gear. So tighten it there. Is it tight? Yeah. And then, as always with these collets, is this clean? Well, this one also has a taper and it needs to be cleaned. If there are any chips in between this collet and this nut, they will make your tool go not straight. Okay. This is always somewhat difficult. Okay, there it is. And then and always put it all the way in. And this one is not the correct tool. This one is the correct tool. We have it there. Then let's go to the back side. And this is pushing the limits of this milling machine. Now what I want to do here is to touch. Put it in free gear. So I can turn it like that. This is just ordinary office paper. So the thickness is quite exactly 0.1 millimeters. Yeah, it is now in the correct place. So now I reset my dial here, 0, and remember it was 0.1 millimeters, so not in 0 but in 0.1, like that. And this is always oily. Well, okay, there is a scale. Oh yeah. This time I get it exactly on 0. Well, it's on 0. Next step is to touch this surface. And well, this is quite straightforward. Let's go there. There you are. This one. And 0.1 millimeters less, like that. And now we need to cut 10 millimeters deep, but I will leave 0.5 hundredths of a millimeter for the dovetail cutter. So there, now it's on level. So that would be 10, but as said, I will leave 5/100 of a millimeter. And let's lock it. We don't touch that anymore, that's where it is now. So I will be making 3 separate cuts here. First being 3.3, then another 3.3 and finally 3.4 millimeters. I'm going to use coolant. Yeah. Doesn't go nowhere after that. And then we are using splash guard, the biggest one I have. Well, I do need to see what happens here. This is something I need to take care of. Okay, let's take another piece of. Okay, this might be better. Okay, that's good. Okay. Stop. That's it. Oh, now we can raise it. Oh yeah. So, the next step, I will change the cutter to the dovetail cutter, And after that we will start milling the actual dovetails. This was just preparing for that one. This is the last pass for this side, and yeah, it has been working quite well, and I was able to take 2 mm passes, so advancing 2 mm, so this is the third pass, and now it's finished, so actually faster than I thought it would be possible. Well, but the amount of chips is increasing every pass, and now I believe I need to clear some of these because I want to avoid the recutting, and this is very bad if it happens. Okay. No chatter. Now I will do climb milling without touching anything. I just do climb milling, and I have noticed that the surface here, there are deviations in the surface. It's not completely smooth. I know it becomes smoother after doing well, a spring pass, if you like. So, well, just do it. This is a lengthy process, and I will not show it to you. I will let it do it off the camera. So, see you when I start doing this side and the other side. The other side, the back side here, Now the surface is really smooth. I can't feel any bumps with my finger there, so it should be really usable. Now we just repeat the procedure this side and then we are done. Deburring station. Well, this is the piece I already did debur for the other side. This is the other dovetail side, and this one has burr in all corners. And this one especially, the sharp one, has a horrific burr. So I'm using two files to get rid of this. This one has one straight cut, which I'm using. And then I have another which is half moon shaped. It goes into the tight corners where I need to do some deburring as well. So, first this corner, which is the most horrific. How I do this, I will support the file like this, grab it really, and then push. It's really simple, just push. And go like that. And do this a few times. Oh, that was easy. And now we have a little bit of burr in the underside, and this is a functional surface, so you need to be really careful with this one. And then these horrific corners. Well, you just pull it away from there. Yeah. So, next step will be some oil grooves into this one. The weapon of destruction for the oil grooves is a slitting saw. And well, I probably could use an end mill to mill those grooves, but somehow I feel this one works better in this milling machine. So that it will be. So let me now arrange this, dial it in and do a metamorphosis for this this thing so that it becomes an horizontal mill. And then we go on slitting. fitting saws keep on surprising me every time. Now it was really loud and with vibrating and the worst of all is these chips. They are like small needles and they are everywhere. And now, I managed to get them out of my fingers with the needle pliers and a strong neodymium magnet. Anyway, it's now done. The grooves for oil wigs are now there, and next step would be drilling the oil system there, so that there is only one entry point for oil to oil the tin. Yeah, but that one will be in the next episode of If You Know Great Machining. Till then, bye!